So in this related rates question, we read that a spherical crystal is growing at a rate of 1 cubic millimeter per minute. Okay. Find the rate at which the radius is changing when the surface area is 8 pi centimeters squared. Okay, so we got a couple of things going on here that we're going to have to pay a close attention to as we move through this here. So first of all, we're looking at a sphere. Here's my radius. Okay, I'll just zoom in. Whoops, I'll zoom in a little bit here. First of all, we're going to identify what is it that we know. Okay, well, first of all, we know we got a sphere here, and we're talking about the rate of change, sorry, how fast it's growing, and we're talking about the volume changing because we got cubic millimeter per minute. So volume, okay, the volume of a sphere is 4/3 pi r cubed. I know that. Okay, I also know from this question here that the rate of change of volume, okay, is 1 millimeter cubed per minute. Okay. Now, I am looking for what I want is the rate at which the radius is changing. I want dr by dt. Okay, well that's perfect. My equation then is going to work out perfect for me because there's only two variables here. I know the rate of change of one of the variables. I'm looking for the rate of change of the other variable. So I'll just take the derivative a couple seconds here. Now, find the rate of change, at which the radius is changing, yeah, dr by dt, when the surface area is 8 pi. Okay, so what is that trying to tell me there? Well, the surface area is 4 pi r squared. Okay, I know that. So let's take that and let's figure out what it is that they're trying to tell us here. So my surface area is 4 pi r squared. They're telling me it's 8 pi. 4 pi r squared. And you should see right away here, what they're trying to tell you here is what the radius is. I'll divide both sides here by 4 pi. We'll get 2 is equal to r squared. R is equal to either the positive or the negative root of 2, but that doesn't make much sense to talk about it in terms of the negative. So this has got to be root 2. Okay? Now, that is really interesting because root 2 what? Okay, root 2 what? Bear in mind that we are being told that the volume changes with in terms of millimeters cubed per minute, but we're told that that surface area was 8 pi centimeters squared. So this was a centimeter squared, so I can assume that this is actually centimeters. Now, I want to be consistent here, so I just got to choose one of these units to work in because it really didn't give me any indication here. But you know what? I was told how fast the volume was changing with respect to millimeters. So what I'll do is I'll just change this to millimeters. So, and therefore the radius is going to be root 2 divided by 10. Oh, sorry. No, that's right. No, it's not. If I wanted to convert that into, sorry, I'm having a bit of a brain fart here. This is going to be like 1.4 centimeters. I got to multiply that by 10. Sorry, had a weird little moment there. I got to multiply that by 10 to convert that into millimeters. So there's the radius that I'm working for here, or that I'm working with there. Okay. Now, let's go through and start this problem here. So we're going to start with volume is equal to 4/3 pi r cubed. Okay, we're going to take the derivative with respect to time. I've got to do this implicitly because time doesn't show up as a variable in here. So this will be 4/3 pi 3r squared. Okay, there's the chain rule, or there's the first part of the chain rule. Now I'm going to multiply by dr by dt. The second part of that chain rule is taking the derivative of what's inside there as a function of time. Now I'm going to plug in the stuff that I know. I know that dv by dt is 1. 3's are going to cancel here. This will be 4 pi. My radius was 10 root 2. This will be squared. And then multiply by dr by dt. And dr by dt is what I'm looking for. So now I'm going to bring this all over here. Now it turns out this works out to be really nicely here. This is going to end up being 200. Okay, 10 squared is 100, root 2 squared is 2, so it's going to be 200 times 4, 800 pi. So when I divide, it'll be 1 over 800 pi, and this is going to be millimeters per minute. okay, because I changed the units here to millimeters. And you know what? Now I can actually evaluate this in terms of a decimal value here just to give us a sense of how big this number is. So 1 divided by 800 pi. Ooh, and we get here, this is going to be 0. What do I got here? 1, 2, 3, 4 millimeters per minute. Well, that is really quite slow there. That's okay. You kind of expect that with crystal growth. You wouldn't expect it to be super quick anyway. Anyway, there you go.